tomorrow we will be, tomorrow's assignment, or what we're going to do in class, is basically more of a review of what we've been doing the last 2 days or 3 days, drawing or writing the word equations, formula equations, and either drawing and balancing the equations. What do you mean more than one reaction?
Like, say it was like barium oxide plus barium sulfide plus water. I mean, I know it would be 2 bariums, but...
Oh, like, so more than 2 reactants? Yeah, we will see more than 2 reactants. All right. Are we ready to go? Okay. All right, so first of all, formula equation. What is the formula for barium sulfide? BAS. Water. Barium oxide. Barium is a, please take the earbuds out and turn it off. Barium is a +2, oxygen's a -2, so it is BaO. And hydrosulfuric acid, so H2S. So it says hydro at the front, so it cannot be sulfate or sulfite. It has to be just sulfur. Okay, any questions on that? The next thing we need to do is we need to draw these particles. So I've kind of given a key over here, and we're going to just draw what we see, the formula. So if I have a BA, so I need a BA here, and I need a BA over here. And BA here is hooked up with an S. So I'm going to put an S here. And I need an S over here with the hydrogen. Now we have our H's, so I need 2 H's. So I'm going to put, oops, that's not an H, need blue. So I have an H here and an H here, and those are hooked up to our oxygen, which is red. And then I have it over here on my sulfur. And then lastly, I have my oxygen with my barium. Okay. So we have drawn that, and now we need to look and say, is the law of conservation of mass being observed? Do we need to add more atoms? That's good, right? Okay, so we are good to go. Any questions on that?
Why is it not BASO3?
Why is it not BaSO3? Because this says sulfide. So SO3 is, or SO3 is sulfide. sulfite. And SO4 is sulfate. So anytime you see that ending in "ide" like that, you're probably going to go to the periodic table and find that element.
Thank you.
Any other questions on that? Okay, so let's go to our notes. So what we're going to talk about today are coefficients, or balancing. So the first thing we need to do before we can learn about balancing is we need to learn about coefficients. So coefficients are the number that you see in front of your substance. In this class, that number is a whole number. We will not do halves or decimals or any of that stuff. It should always be a whole number. That number goes to the front of your substance. So it is in front of your formula. Never in the middle. Okay? So I cannot say Fe2O3. You cannot put a whole number right there in between your compound just to get to where you need to go with your number of atoms. So it's never in the middle of your formula. That coefficient, that number at the front, distributes, which means we're going to multiply, to everything in the substance. So this 4 distributes to that Fe. This 3 distributes to that O2, which tells me how many O2s do I have? 6. And I have 4 Fe's. That 2 distributes to the Fe, so that's a total of how many Fe's? 4. And that 2 distributes to the oxygen, so that gives me 6. The next unit, we're going to be using these a lot, and I'm going to say 2 moles of Fe, and that means that coefficient is 2. Or here, 4 moles of Fe. So that number in front means that's the number of moles that we have.
Do we get to use this sheet on this quiz? Not on the quiz, either.
Okay, so the number of moles is the coefficient, that coefficient. And we are going to use these to balance the equation. So we're going to put numbers in front of our substances, or those equations we've been writing for 2 days. We're going to put numbers in front of them to help us balance the equation. So if I have So if I had 5 moles of calcium phosphate, we're going to be distributing out my 5 to everybody in the compound. And then if I have this parentheses, that subscript outside the parentheses gets distributed to everybody inside the parentheses. Okay? So, looking at this, how many calciums do I have? 5 times 3. 15. How many P's do I have? I have 2 times 1, so that's 2, times this 5? 10. All right? And then how many oxygens? I have 2 times this 4, which is 8, times this 5. 40. Okay? So if I have 5 moles of calcium phosphate, then that 5 moles contains 40 oxygens, 10 phosphorus, and 15 calciums. And the total number of atoms in that 5 moles would be 65. Add them up. Okay? Any questions on that? So when I start to balance things, the only thing we can add are coefficients. We can never change our subscripts unless you've written the formula wrong. But if your formula is written correctly, you cannot change the subscripts. If you change the subscripts, you change the formula. We don't want to do that. So what I do is if I have an equation, I go through that equation and I label or I pull out bits and pieces from each side. So the first thing I always write are my polyatomic ions. So say I have So if I have that equation, what I like to pull out first are the polyatomic ions. So I go and I look. Do I have a polyatomic ion in these equations?
Yes.
I have one here. And is it over on the other side? Yes. So I start making a list. And I make my list. My polyatomic ion. I'm going to treat it as it's one thing. And then my next thing is I go and I find my metals. So my metals, I'm going to list my metals. And what metals do we see? We see Na. So I'm going to list Na. And what else do we see, metal-wise? Ca. So I'm going to put Ca. So we have Ca. And then lastly, we are going to go and grab our nonmetals. So nonmetals, chlorine. So we list that. That's the list of everything we have. If I have some H's and some O's in there, then I'm going to put those next. But in this equation, we do not have any H's or O's that are not hooked with something else.
I finally got that one.
So if we had H or O, we would put it next. And then what would happen is we're going to start putting some numbers in there. And if our numbers, when we start putting numbers, say this coefficient's a 2, this coefficient's a 2, this coefficient's a 2, and this coefficient's a 2, and I can simplify, we're going to simplify by dividing by the GCF. All right? And then we're going to check it at the end. So let's take a look here. So how many SO4s do I have on my reactant side? I have 1 on the reactant side. How many do I have on the product side? 1. How many sodiums do I have on the reactant side? 2. How many do I have on the Product side. How many calciums on the reactant side? How many calciums on the product side? How many chlorines on the reactant side? How many on the product side? 1. So I'm going to look, and I'm going to compare those numbers, and I'm going to say these numbers are not equal. I have 2 NAs going in, but I only have 1 coming out. So I need to decide what to do. I can't divide to get to what I need to get to. So I'm going to have to multiply these by a number so that we can get it to be equal. So SO4s are good. NAs. How are we going to balance the NA? We're going to add a coefficient right there. When I add that coefficient in there, how many NAs do I now have? 2. That also changes my chlorine. So how many chlorines do I now have? 2.
So, like, say you it was sealed, would you just, keep, if you needed to, could you put another 2 in front of the CA and then keep balancing it until,
Okay, so the thing is you can only manipulate the numbers in the front, the coefficients. You cannot change any of those compounds. You cannot add more compounds in there. All right, because you're changing the whole reaction. If I needed more oxygens, I can't just say, oh, let's just throw an oxygen here. Okay? Does that make sense? All right, so let's go do... This is just what I said before. Never change the subscript. And 2 NaCl is okay, but you can't say Na2Cl. If I needed 2 chlorines, I can't just throw a 2 in there in front of that chlorine. It's not correct. Okay. Mercury 2 nitrate. What's the formula for mercury 2 nitrate? Mercury is Hg. Nitrate is NO3. Hg has a charge of 2. NO3 has a charge of -1. So we need 2 NO3s. Plus ammonium sulfide. Ammonium is NH4. Sulfur is S. Ammonium's a +1. Sulfur's a -2. So what's the ratio need to be? 2 to 1. So for every 2 NH4s, I need 1 sulfur. It's going to produce mercury 2 sulfide. Mercury's a +2. Sulfur's a -2. So my formula is HGS plus ammonium nitrate. Ammonium's a +1. Nitrate's a -1. So it's just going to be NH4, NO3. So once you have your equation written out, then I go and I start listing my polyatomics. NO3, so I've gotten that one. NH4, then my metals, and my nonmetals. And I have no H's or O's. So now we start listing. How many NO3s do we have? We have this NO3, and we're keeping it as 1. We have 2 of them. Over here we have only 1. How many NH4s do we have? 2. How many do we have on the other side? 1. How many HGs do we have on the reactant side? And on the product side? How many sulfurs do we have on the reactant? And on the product? What? All right, is what's going in the same that's coming out? No. So how are we going to get this to balance out? So added to here. That means now I have 2 NH4s, and now I have 2 NO3s. Yes?
Is there ever going to be ones where, like, you have to multiply one of them, but it changes the other one, so you have to fix the other one?
Yes.
Okay.
You will. You'll be working along, and you're going to go, oh, dang it, I've got to go and fix that one now. And then I've got to go fix this one now. All right. Another thing is, I like to work with the polyatomics. If you don't like having them as polyatomics, then you can go in there and you can just list your metals first, and then your nonmetals, and then your H's and your O's. Okay? So you can list them as using these as ones, or you can list them as each individual atom. I don't care. If you're a person that can look at it and go, I don't need these, I know that I need a 2 over here and I'm good. I'm not going to check that you're listing them. I'm going to check that you have that right coefficient. So some people work different ways. The next thing I want to say is that, wait. I think that's good for right now. I know I had something to say and I've kind of forgotten it. So let's go work another one. Iron 3 hydroxide. What's the formula for iron 3 hydroxide? Fe is a +3. Hydroxide is OH, and it's a -1. So the ratio needs to be FeOH3. That 3 distributes to the O, it distributes to the H. And that's going to produce iron 3 oxide. So iron is a +3, oxygen's a -2. So we need a 2:3 ratio. And water. So list your polyatomics first. Do we have a polyatomic? We do, but is it over here? No. So we're going to just go with our metals first. So iron, and then our H's and our O's. So how many irons on the reactant side? 1. How many on the product side? How many O's on the H's on the reactant side? 3. How many on the product side? 2. How many O's on the reactant side? How many on the product side? 4. 3 plus this 1. So that is 4. Is everybody okay with that? So you've got to, when you see that if there's one here, and you're adding it to another thing, you've got to add it. So you multiply your coefficients and your subscripts, but when you're adding, and it's on the same side of the equation, you just add them together, whatever you have. All right, so iron, how are we going to get iron to be equal? Times 2. That gives me how many Fe's now? 2. My H's get multiplied by 2, so now we have a total of 6. My O's gets multiplied by 2, so now we have a total of 6. So the next thing we need to do is get our H's and O's in line. So, H, how many H's we need? We need a total of 6. I'm recording. So we have 6. So, oh my gosh. So how many H2Os do we need? 3. That gives me 6 H's. And now how many O's do I have total? I have these 3 plus these 3.
You're going to multiply it by 3, right? So you can get it to 12.
So that gives me 6.
Yeah, don't ask.
That makes sense? Yep. Then I go, do my numbers match up? 2, 2, 6, 6. Yes. Questions? I mean, once you do it a couple of times, you're just like, oh, and then you just don't even start listening to them anymore. I didn't put 70s. Never mind. Okay.
Anybody see me kiss that for
Did you need me to go back? You're good? Okay. Antimony plus chlorine. What is antimony's? SB. And chlorine is Cl2. I get antimony trichloride, so 1 antimony and 3 chlorines. So we have SB and we have Cl. So how many SBs do we have on reactant? On product? How many chlorines on reactant? How many on product? 3. So our SBs are good. Let's go do the chlorines. So what is the common number between 2 and 3? 6. So we can multiply our Cl2 by 3. That gives me 6 of those. I go over here to SbCl3 and multiply it by 2. And that gives me 6 chlorines. But now my SBs are messed up. So now I have 2 SBs. So then I'm just going to do a 2 over here and change that to 2.
I kind of like how you put equal signs on that.
Huh? I'm sorry. I don't usually put equal signs, and I don't know. I've been doing that today. Like, I've been just like off today. Some of them I put an equal sign, or some of them I just do a dash. I don't know. All right. Good? I'm going to do one more. And then I think the next one, I'm going to do example 11, I think it is. And then I'm going to do one from your homework. Yes?
Okay, after you did the 6 on both sides,
Mhm.
why did you do 2? I didn't see the SB part, sorry, I was writing.
So what happened was when I changed this to 6, I put this 2 here, which changed that chlorine to 6, but it changed my SB to 2. Okay?
That's what I thought.
Okay. Let's do this one right here, but we're not going to do methane. We're going to do something else. We're going to do C3H9 plus oxygen, and that gives me carbon dioxide and water. Now, if I were you, I would just stop right there and don't copy anything else, because you're going to get mad at me, because I'm going to be doing some erasing and craziness and stuff. So the very first thing I'm going to do is I'm going to list what I have. I have 3, 1, 9, 2, 2, and 3. When I start looking at this, I see I have some odd numbers here. I have an odd number here, I have an odd number here, and it's going to make things kind of awkward, but it'll work out in the end. So, this would be one of those super bonus problems. Super bonus. So how many carbons? I'm going to go with 3.
So don't write it.
Don't write anything down. How many oxygens do I now have? 6 plus this 1. 7. Now, let's go do our H's. If I have an odd and an even number of H's, the best thing I'm going to do is I'm just going to multiply this one by 2 and the other one by 9. So I'm just going to multiply this by 2, which gives me my H's at 18. My C's become what? 6. I go over to H2O and I put 9. Now I have 18. But how many oxygens do I have? I have 6 plus this 9.
15. 6 plus 9 is
6 plus 9 is 15. Okay. So, but what happened to my C's? I have 6. So what do I need to put over here? It needs to not be a 3 anymore. It now needs to be a 6. I told you this is. Now how many oxygens do I have? I have 18 and 9. Oh, sorry, 12 and 9. 21. That was me. 21. Oh my gosh, this gives me a headache. I cannot do halves at all in this class. So the thing I'm going to do, so I can get it to an even number, I'm just going to leave an oxygen. I need to get oxygen to an even number. So the first thing I'm going to do is I'm just going to double everything I've already written. This becomes 4. This becomes 12. This becomes 18. All right, let's see if it works out.
But why?
But why? Because I have that 9. I want that 9 to be an even number. I have 9 oxygens. I need to get to an even number of oxygen. So the best thing is to multiply everything by 2 to get out of that even or that odd number. All right, so how many carbons do we have on the reactant? 12. How many hydrogens?
36.
36. How many oxygens? 2. All right. How many carbons on the other side?
12.
How many hydrogens?
36.
36. How many oxygens? 24 plus 18. 32? 42? 42. So how many O2s do I need? 21. So this is one of those super problems. Am I able to simplify? No. That's it. Yes.
Wouldn't C3H9 be just like CH3?
If it was, it would be for the molecular formula, but the empirical formula is C3H9. So remember, you can't simplify down your molecules, right? Okay. So this is a super problem. I would not do something like this on the test, but
I hope not.
I might do one for bonus.
Like on the quiz?
I'm not going to do the same one.
Wait,
No.
you said you're recording?
Yeah.
I may hear you say, yeah, I'm going to get my HOs in line.
Okay. So last one. Go to your homework. And it was number 10 on your homework.
Are you still recording?
Mm-hmm.
Let the video show I did not once.
So first of all, you need to make sure that your equation is right on your homework. Number 10. So that would be the correct formula on number 10. And I'm going to tell you right now, number 1, 3, and 13 are already balanced if you did it correctly. If you did 1, 3, and 13 correctly, they are already balanced.
Can we do our balancing on a separate sheet?
Yes, you can. Okay. So I'm going to list my polyatomics. PO4. And I have an OH here, but do I have an OH here? So what I do sometimes, and it works out most of the time, you can leave it alone, but I find it's easier, especially when we start doing other equations, as I'm going to call water HOH. Most of the time, sometimes it doesn't. It starts to get weird. This is one where it works out great. I call it HOH because that's all water is. Water is a hydroxide ion, and it's H ions. So water is both an acid and a base. So I can write it to where it looks like it's both an acid and a base. You don't have to. You can go back. You can take a picture of it or whatever. Then I put my OHs. I put my Na. I put my H3 H's.
Wait, why didn't you put OH first?
Why didn't I what?
Put OH first.
OH first where?
Like, are you supposed to go left to right, or does it not matter?
It doesn't matter. It doesn't matter. So my PO4s, I have one of them. One. My OHs, I have, and if it's good for you to do that, I have one. And I have one. My Na, I have one. And I have 3. My H's, I have 3. And I have 1. So PO4 is good, my OHs are good. So to get my NAs to 3, I'm going to put a 3 here, which gives me 3 NAs. But now how many OHs do I have? I now have 3 OHs. Huh?
Oh, no, I was talking
Okay. Now I go to my OHs over here. I only have 1. So what does my coefficient have to be? Is a 3. And now that gives me 3 OHs. Okay. And how many H's do I have? 3. Okay. So one of the things I want to say, I now remember what I was going to say. What are the coefficients that make this problem balanced? We have a coefficient of a 3, then we have a 1, then we have a 1, and we have a 3. Does everybody understand that right here, there is not a number there, but it's an understood 1. When you go and you take your test and you look at it and you balance it, you're going to say that it's 3, 0, 0, 3. Because you're not going to see that number there. And you're going to forget that it's an understood 1. But you will be given questions like that where I'll say, what are the coefficients that correctly balance this equation? And I'll give you a mix-up of 1, 3, 1, 3, 3, 1, 1, 3, 3, 0, 0, 3.
Should we go like left to right on the...
Yes, it would be left to right. And then also I might say, what are the coefficients when added together, the sum of the coefficients when added together? So if it's correctly balanced, the sum of the coefficients would be 3 plus 1 is 4, plus 1 is 5, plus the 3 is 8. You might say it's 3 plus 0 plus 0 plus 3, which would be 6. So you're expected to know how to balance them, to tell me what the coefficients are in order, or to give the sum of the coefficients. Be able to look at that and give me the sum of the coefficients. Those are all variety of questions that will be asked of you. Are there any questions over that? So your homework tonight is 1 through 13 on the front page and to just balance them. Again, 1, 3, and 13 are already balanced.